Hey, welcome back to my video blog. Today's video actually is a little response to when I got comments on the video making this little adapter for this SO8 to DIL package for my breadboard. People complained about not using enough flux when soldering those. And actually I had a little problem that when using too much flux I got the solder fumes all over my face, my eyes, and it was just terrible to work under those conditions. So what I did today is I made a little solder-fume extractor so I could solder smaller parts and getting really up close and intimate to those. And in today's video I'll also be experimenting a little bit with different backgrounds, different lightings. I'm gonna be trying to show the way the solder fumes take into the extractor when using the fan. So please give me feedback about the lighting and which background you prefer. I can show you the difference. Normally I just use my table like this. So the background is really light and the contrast isn't that good, but it's maybe just a little bit more attractive to look at. I'll let you decide if you like the blue velvet background or the standard table background. And now I'm gonna show you the Solder-Fume extractor I made. Okay, so here it is. It's actually nothing I built on my own. I just took apart a PC power supply and used the fan and the case part like this, so you can just put this upright and mount it wherever you wanted it. What I built myself is this speed regulation using a PWM modulated output to a transistor that then switches on and off the fan at a rate of about 20 kilohertz. I chose this pretty high frequency because I didn't want to be able to hear any switching noises, and if you get in a frequency, in a hearable frequency range of say 1 or 2 kilohertz, it can get pretty annoying. So I put it up as far as it seemed practical for me. Really nobody but really small children are able to hear 20 kilohertz. I myself, I'm not able to hear it, and I didn't want to go any higher in frequency, so you wouldn't have to consider any high frequency switching optimizations for the circuit. At this frequency range it's really simple and easy. It's just built using a standard NE555, so I can show it to you in action. I'm just gonna switch on my power supply and the fan starts running. You can barely hear it because the speed is turned down pretty much. If I turn it up, you can hear it gets pretty loud, so you have really much headroom in terms of spinning speed if you need more airflow to get more of your solder fumes out. For my applications and when I'm soldering really up close, I just keep it in a position like this. So now I'm gonna show you what's the schematic I used. So this is the schematic I'm using. It's just a 555 timer in standard configuration for PWM signal generation. It works in the way that this cap down here is charged through this branch of the potentiometer and is discharged through the other one via these two diodes. So if you change the slider position of the pot, you change the difference between the charging time and the discharging time, and thus you're changing the pulse width for your output signal, and then it gets fed into this N-channel MOSFET over here, which low side switches the load, which is in my case the fan for the solder-fume extractor. And for the last part, I'm just gonna show you a really close-up shot of the tip of my soldering iron when melting tin or solder, and the fumes that get extracted. That's the part where I use different lighting setups. So if you got any recommendations on how I should set up my lighting or make things different, just tell me. So far, that's all about this video. Thanks for watching. If you liked it, subscribe, rate and comment, especially comment on what I can do differently in terms of camera setup and lighting. Thanks a lot. Bye bye. See you next time. Here is how it works. And look at how the smoke gets pulled into the fan and won't reach your nose, your eyes, and distract you while soldering.